Back in actually 1995, I began to see the potential for using the satellite imagery that's collected from a satellite called the Advanced Very High Resolution Radiometer satellite. This satellite goes over every day, twice a day. There's two satellites, so we get a morning and afternoon picture. If there's clouds in the way, we can't use the image, so we take multiple pictures and put them together to create cloud-free composites. What we do when we make our maps is we use an index. It's called the Normalized Difference Vegetation Index, and that index is very sensitive to differences in chlorophyll concentrations in plant leaves. So we've got live plants that are photosynthetically active. The more plant material we have, the higher that index value goes. So you can see low areas on this map we're seeing here. Areas that are colored in yellow have a lower index value, and areas that are green have a higher index value. In this particular map, you can see where the corn belt for the United States is quite clearly. That dark green area is the corn belt. And unfortunately, Kansas is sitting under here, under some of these letters. But that's the index that we use. And we simply just compare that to this week compared to the previous week, this week compared to the previous year, and this week compared to the 21-year average. So because of that, we get a map every 7 days. So we get 52 of these maps a year. And that allows us to build graphs. And in this particular example, the graph that I'm talking about is right here, and it's probably too small to be seen. But what this is simply plotting that index over the entire growing season. So what we see is when the plants start to green up, how quickly they green up, when do they reach maximum greenness, how long do they stay green down here, this value down here. There's 12 different variables that we can extract from that graph that allows us to monitor the vegetation conditions and how they're doing this year compared to other years. For example, this green up. If we have bad growing conditions where it's dry, the plants are not going to green up as fast, and the slope of that line is not going to be as steep, or they're going to brown down more quickly. So that influences the quality of the grain, and this line right here, the faster that line is for winter wheat, for example, some have suggested that might be tied to gluten content. Corn browns down very quickly, it probably is not going to be a high yield. And so we can use this graph to study what's happening with those crops. For every 250-acre area in the conterminous U.S., we can monitor it on a weekly basis. Now, this one over here, some people say, well, the detail of this particular satellite imagery is not detailed enough. Well, one thing I'll point out, that is Stevens County down in the southwestern part of the state of Kansas. And what I've got here is the approximate location of the rainfall gauge in Stevens County. And all those little squares on there are what we call the pixels from the satellite. I've blown it up so large you can see the individual pixels. And the green areas are areas that are greener in Stevens County, and the yellow areas are areas obviously are not as green. But one thing we see is that there are 2,600 pixels in Stevens County, and there's one rainfall gauge. So we say, how does this compare to rainfall? 2,600 times more detail for Stevens County than there is from the rainfall data. So you can see what's happening all over that county, much more detail than if I just have the one rainfall value. And this is the graph I was talking about earlier, when the plants green up, how quickly they green up, how quickly they brown down, how long they stay green. There's 12 different variables we can take from that. All of those can be related to some important factor that relates to what our vegetation is doing.